Good morning, guys. Today I am going to recap what we did yesterday in section 6.3, where we simplified complex fractions and also go over how to simplify a nested fraction. So I know that these two examples are what we saw in class yesterday, but I thought it would be helpful to go back through it. That way you guys can rewind, pause, and watch both of the methods again. So number 2 from yesterday, we have this complex fraction. I'm going to solve this using method 1. Method 1 is to multiply the numerator and denominator of your big complex fraction by the LCD of all of the little denominators. In this case, our LCD of all the little denominators is a squared. So multiplying top and bottom by a squared. That in red is an equivalent of 1. Anything over itself equals 1. So we are going to distribute a squared to both terms on the top and all three terms on the big bottom. Notice when we multiply, we're actually multiplying by a squared over 1. We're multiplying a squared to the top, all the little numerators. So our numerator is going to be a squared minus 4 over a squared times a squared. So the a squareds cancel. So that's just negative 4. The denominator, a squared times 1 is just a squared. A squared times 5 over a, one of the a's cancel, so minus 5a. And the last term, the a squareds cancel, so you're just left with 6. Once you have this fraction, try to factor and simplify this as if we are back at section 6.2 part 1, 6.1, to get this fraction just to be as most simplified as we can. So factoring, a squared minus 4 is difference of squares, a plus 2, a minus 2, and the denominator is a minus 2, a minus 3. Any common factors you cancel, so we both have an a minus 2, one on top, one on bottom. So your final answer is going to be a plus 2 over a minus 3. So that is method 1, finding the LCD of all the little denominators, distributing, getting a fraction, factoring, canceling as much as you can, and that is it. Method number 2 from number 5. What you do is you treat your numerator and denominator as two separate problems, as if they're back at section 6.2. So we have to find a least common denominator for x plus 1 and x. So that is going to be x and x plus 1. So our first fraction here needs an x. The second fraction needs an x plus 1. Notice we have a subtraction sign, so we got to be careful there. So our numerator is going to be x minus 2x minus 2 over x plus 1 times x. Simplifying that, we have negative x minus 2 over x plus 1 times x. We're going to pause and hold off on that for a minute, and we are going to treat the denominator as its own problem as well. So x plus 2 and x plus 3 are two completely different denominators. So this one needs the x plus 3 and this one needs the x plus 2. So we have 3x plus 9 plus 5x plus 10 all over our two denominators. Simplifying this, 8x plus 19 over our two denominators. So we have the red fraction divided by the blue fraction. Division of fractions you keep, you change the division, and you flip the denominator. So we are going to have negative x minus 2 over the x plus 1 times x times the flipped of the blue. So 8x plus 19 is on the bottom now, and x plus 2, x plus 3 is in the numerator. Check and see if you can cancel any common factors, one on top and one on the bottom. Yesterday, some people saw that we could take out a negative 1 here, and that would be negative 1 times x plus 2. but there is no x plus 2 on the bottom. There is one up top here, but you can't cancel across the numerator. So this multiplied all together is negative x minus 2 and x plus 2 and x plus 3 all over our three denominators. If you saw and you took out a negative 1, your answer could be x plus 2 squared. One from here and one from there, the negative on the outside. X doesn't need to be in parentheses by itself. I just always do that to make sure I don't forget about it. So your answer could be this one or this one. Your book would have the bottom as the answer, but I would accept both of these answers. So method 2 is treat the entire numerator as its own problem, get an answer over here to the left, over here to the right, the red. Then get a least common denominator and treat the entire denominator of our big complex fraction as its own problem in blue here on the right. And then you treat it as its own division problem, a fraction divided by a fraction, keep, change, flip. Cancel if you can. This one was not a great problem because nothing canceled, so our answer has every single piece. Most of the time you will have something that cancels. All right, now let's look at a nested fraction. Yesterday I brought up that a nested fraction is like the movie Inception. You are dealing with a complex fraction inside of a problem, inside of a fraction, inside of a problem, inside of a fraction. So we have to keep going and get out of each of the layers until we are left with just one fraction. One numerator over one denominator simplified. So we're always going to be starting with the bottom here. So 3 minus t, that's simplified. So move out. 1 over 3 minus t, that's simplified. Keep going out each layer. So now we have 2 minus 1 over 3 minus t. That is not simplified. We have to combine to make it one fraction. So we need a common denominator. The common denominator is going to be 3 minus t. So in green up here, 2 times 3 minus t minus 1 all over 3 minus t. I just took the 3 minus t and I'm multiplying it by 2. So this is going to be 6 minus 2t minus 1 all over 3 minus t. Combining like terms, we get 5 minus 2t over 3 minus t. That is what the green simplifies to. So right now we have 1 over 1 minus 1 over the green. So that green oval up here simplifies to what I have in green there. Okay, now branching out one more layer. Now we have this. 1 divided by the green. When you divide by a fraction, you flip. So we are going to be flipping the green fraction underneath the 1. Since we have that, I'm going to put it over here. 1 divided by that 5 minus 2t over 3 minus t. So keep, change, flip. 1 times the reciprocal. And that answer is just going to be 3 minus t over 5 minus 2t. So that is what is in red. Okay, now we have 1 over 1 minus our new fraction here because we had to flip it. If this 1, which I'm going to highlight in yellow, if this 1 was a different number, then we would have to multiply the reciprocal, that 3 minus t, by whatever number that was. But since it was 1, we just had to flip the green fraction up here. All right, next one, branch out one more layer in our inception here. We have to subtract 1 minus that red fraction. So we need a common denominator. The common denominator is going to be 5 minus 2t. So 5 minus 2t is being multiplied by the 1. I know I don't need it there, but I'm just showing you where it's coming from. All over 5 minus 2t. Distributing, there is no distributing, so we have 5 minus 2t. Oh, glad I checked that. It's a subtraction, so this needs to change to a plus. So we have minus 3 plus t all over 5 minus 2t. combining like terms, we get 2 minus t over 5 minus 2t. This is what the blue simplifies to. So now we have 1 over that blue fraction, 2 minus t, 5 minus 2t. All right, our last one here. We now have the final step. I shouldn't do it in red because we already used red. Let's do orange. All right, final step here. We have 1 divided by that blue fraction. All right, like we did up in the red one, we had to keep change flip up here. So this one here, our numerator's 1, so we know that all we have to do is flip the denominator. And this is our final answer. If the numerator had a number, then we'd have to multiply our new numerator by that number. All right, so I'm just going to scroll up. Please hit pause to look at all of the steps here. I tried to color code it so that you could see. I will also post this slide here as a PDF for you to look at each of the steps. I hope you guys have a great day. Let me know if you have any questions, and we will work on going through this next class. Thanks, guys.